Hello everyone, myself Anurag Mandal, Assistant Professor of EC Department. Welcome to the series of lecture on digital system, that is the subject in the Computer Science Department second year. And today we are just going through the topic that is the number system, and it is the part number one. So in this particular session we are just going through this contents. They are the motivation, then what is number system, then types of number systems, and within this type we have the four main types, and we just go through each and every types, and it's counting. Okay, and at the end I just show you that other number systems are also present, and how to represent that other number systems, and I just conclude this session with some quizzes. Okay, so let's start with let's start with our first topic, that is the motivation. Okay, so motivation means why we just study, we are going to study this particular topic, that is the number system. Okay, I should just show you one of the example or one of a image. uh, that image just show you the storing of data within a particular memory. Okay, let me show you first. Okay, so this is a image. Okay, in this image there is, here it is just showing over here that some values are stored in each and every location. Okay, in the memory, and what these values are represented, these values are represented like in this way. Means whatever the red are there, this red are the strings and the green are the digits. Okay, so this particular section, this particular section is known for us, but this particular section is never known for the computer. The computer will only know the 48, 65, 6c, 6c, then 6f for the hello. The computer doesn't know what is HELLO, so it will only know the this particular values. Okay, but as we know that computer will only store the value in terms of, or data in terms of 0 and 1. So 48, this is not the 0 and 1. So what is it? This is the representation of that 0 1 value in terms of hexadecimal number system. Okay, now why this hexadecimal number system is required, or why we need to represent that 1010 data in terms of hexadecimal? Because if we represent some value of any data in terms of 1010, it will consist of, or it will consume a lots of area of representation. Okay, so there is a problem, because we are just represent one single data with a large quantity of area. So that is not desirable thing. That is why a number system is invented. That is the hexadecimal number system. And with the help of that hexadecimal number system, we can represent a large 1010 data in a small way. That is the 48, like 48 or 65, 6c, 6c, 6f, like this. So the number system is important to know. We have to know what kind of number systems are present in the real world, in which and what are the way of representing that number system. Another thing, here, that is the, for an example, that is a 3a. What is the meaning of this a? What value the a represent? So that is why we need to know the number system in detail. Otherwise, we never know the actual value of this 2D, 3A, whatever it is. Like EF, FE, we never know this kind of values. So we need to have the knowledge regarding the number system. Okay, that is the basic thing of the digital system. Next, I'll show you another example, that is the command window. And command window, you just go through this particular syntax, that the IP config, and then you this particular information will come or will appear in your computer screen. This information is just about the IP address of your computer, then the network you just using for network internet purpose. Okay, and the most important thing, this physical address. The physical address is the MAC address, like the identification code of your computer within the network. Okay, so now again, we have seen that C4. Okay, that C4 again the representation of the hexadecimal number. Okay, so we have to know the way of representation of that hexadecimal number, then only you will understand what is the meaning of C and what is the value of this C. Okay, so that is important. Number system is very much important, and that is we are going to learn in this particular session. What is number system? Okay, and then types of number system. What are the they used to number system in nowadays? Okay, then I will show you the other number system and how we can represent that number systems. So let's start. What is number system? Now, as I just told you, that to represent a number, we have to know the different types of number system. So number system is nothing but a representation way. Let me show you the definition. The defined as the system of writing for expressing numbers. Easy way. System of writing for expression of numbers. To expressing the numbers, we just go through the number system. Okay. Next, the value of a number system is determined by 3 points. First is the digit, what is written over there. Okay. Next is the position of that particular number or digit. Okay. And the next one, the base of the number system. These three are the basic thing to know or to determine what is the value of a particular digit in a number system. I will show you with an example in the later part of the video. Let me start with the types of number system. 4 types of number systems are mainly there, mostly used. First is the decimal number system. As the name suggests, decimal means 10. That is why I just write over here, the base becomes 10. Next is the binary number system. Bi means 2. That is why the base becomes 2. Next is octal number system. Octal means 8. That is why I have written over here, base become 8. And at the end, the most important, that is the hexadecimal number system. Hexa means 6, decimal means 10. That combined, we have the base of 16. And in the subsequent slide, I just tell you the detail of each and every number system and how we can count each and every number system. First, start with the decimal number system. As I have discussed, that the decimal number system having the base of 10. Okay, and this base of 10 we can represent in a different way. That is, this particular number system will consist the digit from 0 to 9. Okay, now here is some decimal number like 2, 7, then 4, then 5, then 0.214. This is a decimal number system. Now, each position of the decimal number system is represent with some weight, and that weight is in terms of 10 to the power of something. Why 10? Because the decimal number system having the base of 10. Okay. Now, this 5 having the weight of 10 to the power 0, then 10 to the power 1, 2, 3, and it is keep on increasing in the left hand side of the decimal point. Now, the right hand side of the decimal point also having some weight, but it having the weight of 10 to the power of -1, -2, and -3, and it is keep on decreasing. The outermost digit of the decimal number is also called the most significant decimal number, and the lowermost is called the lower significant decimal or digit. So I'll show you how to represent this particular number in terms of weight, like this way: 2 into 10 to the power of 3, 7 into 10 to the power of 2, 4 into 10 to the power of 1, 5 into 10 to the power of 0, like this way. So this particular decimal number we can represent in terms of weight. In the childhood, we just go through some problems in the mathematics, that is 5, 2, 1. You have to represent this in terms of weight. So what we have right over there: 500 plus 200, 20 plus 1. Then what is 500? 5 into 10 to the power of 2 plus 2 into 10 plus 1. So that is here 10 to the power of 0, 10 to the power of 1, and 10 to the power of 2. Here it is the 10 to the power of 2. So we have to multiply with the weight, okay, with the digit. So in just last slide, I just tell you where you have to remember the 3 points to identify the value of a particular digit. Okay, so for that we have to know what is the digit over there, that is the 5. Then what is the position of that digit? This position is the 0, 1, 2, second position, and we have to know the base of that particular number system. Then you got the value of a particular number or particular digit. Okay, so 5 we have to know, 5 is there, then the base is 10 and the position becomes 2. Okay, so let me show you in the next slide how we can count. That is a simple thing. The counting process, the normal day-to-day life counting, 10 digits should be there. So we'll start from the 0 to 9. Then after 9, what it will do? What comes? That is the 10. But I just show you the counting in a different way. Look at this. Here, starting from 0, start counting until 9. Then whenever the 9 comes, the 10 comes. But 10, we just I just tell you in a different way that 10 means 1 0, and 1 0 to 19 it will continue. Means the LSD 0 to 9 continue. Whenever the 9 comes, the 1 becomes 2 and start 20 to 29. Then whenever the 9 comes, then 3 over here, then 30 to so on. And it will keep on counting till 99. Whenever 99 comes, then 1 is in the third position and both our other digits become 00. And again the counting is continue and it will counting until 199. Whenever the both are the 99, then only the 1 will incremented over the third position, that becomes 200, and it will start counting until 999. And whenever the three digits become 999, then only the counting of the first fourth digit will start, that is 1000. So that is the way of counting of decimal number. Move on to the next number system, that is the binary number system. Now, what is binary number system? As I just discussed that a base is 2. So obviously if the base is 2, that means in the binary number system only we have the 2 digit, that is the 0 and 1. Okay, so how we can represent? Simple way, we have the binary point, and left hand side of the binary point, each and every position having some weight, and that weight in terms of 2 to the power 0 or 2 to the power something. Why 2? Because this is a binary number system. Okay, that is why 2 to the power 0, 2 to the power 1, 2 to the power 2, and so on. And the right hand side of the binary point, we have again the digits, and each and every position of the digit having some weight, that is 2 to the power of -1, 2 to the power of -2, 2 to the power of -3, and like this way. Each and every point having some weight. But one thing you should keep it in mind, that for an example, I just write down one number, that is 1010. Can you tell whether this 1010 is a binary or a decimal? Someone says, sir, it is a binary number as the 1 and 0 is there. Someone says that no, sir, this is a decimal number because 1 and 0 is also present in the decimal value or decimal number system also. So we become confused. After writing that 1010, we never know that whether this particular number is in the decimal number system or in the binary number system. So we have to represent this 1010 in a different way. And that different way is nothing but, if the 1010 is in the binary number system, we have to write this 1010 with a closing bracket and lower subscript with 2. Same way, if 1010 is in the decimal number system, then closing with a bracket and write down 10 in the lower subscript. That is the way of representation mainly. If you don't use this type of way of representation, then what happened? Everyone becomes confused whether this 1010 is in the binary or in the decimal. So let's move on. Again, this particular number, I just represent this particular number in terms of the weight. Look here, I have written over here 2. That means this is a binary number system, and we just represent this particular number with the help of these weights. Okay. Now, how we just counting the binary number system? Look at this. Here, only 2, 0 and 1. So 0, 1, and whenever the 1 comes, then 10 is there. Okay, then 1 becomes 1, 0 becomes 1, then 1, 1, then the third digit becomes 1, and remaining are the 0. And that is why it keep on counting. Okay, so 0 start from 0, then 1, then after 1 it never be 2, it becomes 1 0. Okay, in this way it will count. Move on to the octal number system. Same way, octal number system having the base of 8. So obviously the numbers which contain in within the octal number system, those are 0 to 7. How we can represent? Like this way. This is the octal point. Right hand side of the octal point having some, each and every digit having some weight, and that digit in terms of 8 to the power of -1, -2, -3, and so on. And the left hand side of the octal point having some weight again, each and every digit, and that weight become in terms of 8 to the power 0, 8 to the power 1, 2, 3, and so on. Why 8? Because this is the base 8 number system. If 215 is in the base 8 number system, we have to write 8 over here. Okay, and if the 215 we represent in terms of weighted value, I just write over here 2 into 8 to the power of 2. Why? Because this is the 0 position, 1 position, 2 position. So because of this 2 position, I have written over here 8 to the power 2. Next, 8 to the power 1 and 8 to the power 0 at the end. Okay, so that is the representation or weighted representation of a octal number. Now, how we can counting the octal number? Simple way, start counting from 0, keep on counting till 7, because till 7 we have the numbers. But what happened if we are still counting? Then after 7 it will come 1 0, and it will continue until what? 1 7 only. And whenever the 1 7 is there, then and then the next digit becomes what? 2 0, and it will start continue until 2 7. Whenever the 2 7 comes, that becomes 3 0, and it will still counting until the 7 7 is there. And whenever the 7 7 is there, the next digit in counting, that becomes 1 0 0, and this is the only way of counting the octal number, only containing 0 to 7. That is the main important thing. Next, move on to the next thing, that is the hexadecimal number system, most important number system. As I mentioned, that hexadecimal number system having the base of 16. So what happened? It just having the number from 0 to 15. Okay, now the main problem is 0 to 9, it doesn't have any problem. But what happened if 1 0 is there? Because separately 0 is in the hexadecimal number system and 1 also in the hexadecimal number system. So whenever I just write down 1 0, and that becomes another confusing thing, whether this 1 0 is treated in a separate way or 1 0 treated as a combined way. So that become confusing. That is for 10, 11, 12, 13, 14, 15, and 15. So we are facing some problem to represent the 10 to 15 in the hexadecimal number system. That is why we have the solution for 10 to 15, that is from, we have just represent the 10 to 15 from A to F. So A, 10 becomes A, that becomes B, C, D, E, and F. Like this way. From 0 to 9, we doesn't have any problem, but 10 A, 11 B, then C, then D, E, and F. Okay. How the weights are distributed in the hexadecimal number system? Here it is. The hexadecimal point in the left hand side, each and every digit having some weight, that is the 10 to the power of 0, 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, 3 and then 4. And after the hexadecimal point, that is the right hand side of the hexadecimal point, we have the weights of the 16 to the power 1, -1, -2, -3 and -4, like this way. Okay. Now, how we can count? Same way, start from the 0, 0. Then it will still counting until the 0f is there. Means it will counting from 0 to 15 continuously. And 15 is nothing but the f. Whenever the f comes, 0f comes, then only it start counting again from 1 0. Then it will start counting from 1 0 to 1f, and after 1f we have 2 0, and still we have 2f, and after 2f we have 3 0, and it will start counting, continue counting, and it will counting until f. Whenever the ff come, then only 100 will come, the next number. That is the way we just counting in the hexadecimal number system. Other number system, what are these four are the main number system that we have used in the day-to-day life. This is the most commonly used, but rather than this particular number system, we have other number systems also. Okay, so let me show you the other number systems also. Same thing, base 3. Base 3 means base value becomes 3, and if the base value becomes 3, it will only contain the 3 digits, that is start from 0 to 2. So, and how we can represent the value within the closing bracket and 3 over here. Same way, base 4, 5, 6, 7, 8 is repeating over here, then 9 and 10 is also repeating over here. So this is the way of representation. This is the value of bases. This is the set of digits within this particular number system, and this is the way of representation of a particular number. Means whenever we just write down a number, okay, and we just write down a number, and I just closing a bracket over here, I have to write down the digit over here. Okay, that is the only way. Okay, so that's all about the number system, part number of 1. And in this part, I just go through the motivation part, what the need of our number system. Then I just tell you the definition of the number system. Then the main 4 types of number systems are there. Then each number, describe each and every number system, and at the end I just show you the other number systems also. Okay, so what are the session outcome? Importance of number system in the computer, the motivation part. Then what is the number system, the definition part. Then types of the number system, the 4 common types, that is the decimal, binary, octal and the hexadecimal, and how we can counting. Okay, now use of each and every number system and their counting. Also I just tell you the uses, that decimal number system just we used for the general purpose counting. Okay, then a binary number system is used in the computer for storing the data, okay, or for use of some values, okay, whatever the value we have used within the computer, that is in terms of the decimal, the binary. Then octal and the hexadecimal, these are used for the representation purpose of a data within the computer. Both are the same thing. And at the end, I just go through the other number system, how the other number system we can represent, how many digits are there for other number system, and what are the base value of the other number system. So that's all about the today's session. Next, the most important part, that is the quiz section. First question, that is the why number system are in the form of integer. That means why number system, binary number system. Why not 7.5 binary number system? Why not? Okay. Next, hexadecimal number system having the 0, 10 to 15 are represented as A to 15, and why that becomes? Why? We can represent 0, 10 to 15 as it is, but why that 10 to 15 is represented in terms of A to F? And the next is, what is nibble and bite? Okay, so these are the three quiz question. We just discuss about this quiz question in the next live session. So that's all about today, part number 1. And in the part number 2, we just going to discuss about the conversion of the number system, how we can convert a number system into another number system. That we are going to cover up in the next video. Okay, part number 2, number system. So that's all about today. Thank you.